2.8 distance and midpoint circles preparation. All right, so we have the midpoint formula. The midpoint formula is simply the average of the x's and the average of the y's as a point. And the way you find a simple average of two different numbers is you add them together and you divide by 2. So this formula right here, you can see that it's adding the two x values together, and you divide by 2, and that gives you the x value of the midpoint. And you can see the next part, which is the y, and this is just an ordered pair, right? The ordered pair is always in the form of x, y. So the second one, the y value of the midpoint is just add the two y values together and divide by 2. Okay? So for instance, let's say we want to find the coordinates of the midpoint M of the line segment PQ with endpoints P and Q. So let's say we say this is the first point. So we say this is x1 and this is y1. And let's say the second one over here is the second point, and we therefore make that x2 and y2. Okay. Now the formula is M is equal to, it's x1 plus x2 over 2, and the y part is y1 plus y2 divided by 2. So we plug in what we know. So where it says x1, instead we're going to plug in a -8. And where it says x2, we are going to plug in a 3. Okay? And then we're going to divide that by 2. I'll even plug in the other side where it has the y's. So we're simply going to find the y1, which in this case right here is a 4. All right? And then we're going to add in the y2, which is a -2. I know that looks terrible, but that's a -2. And then we're going to divide that by 2. Okay, so -8 plus 3 is -5 divided by 2. And 4 plus -2 is a 2. And 2 divided by 2 is 1. Okay, so again, we just add the x values together. -8 plus +3 is -5. -5 over 2. We add the y values together. 4 plus -2 is going to give you a +2. +2 divided by 2 is 1. And now we have our midpoint. And that's it. And it's literally what it sounds conceptually, right? It's literally the midpoint. You can see right here that the difference between here to here is equal to the distance between here and here. And that's why we call this the midpoint. It's right in the middle of this line segment, right? So again, this distance, whatever this is, right, that distance is equal to this distance right over here, and therefore we call that point right there in the middle the midpoint. So that's it. Okay, so let's say we want to find the coordinates of the midpoint M of the line segment PQ with endpoints P equal to 4, -3, and Q equal to 6, -1. Again, I'm going to label this one as point 1, and this one over here as point 2. It doesn't matter. You can flip the points and you still get the same average. Two numbers added together, whether you add 4 to 6 or 6 to 4, you're going to get the same answer. So don't be concerned about labeling one as point 1 or the other one as point 2. Okay, so again, we say the formula for the midpoint is x1 plus x2 over 2 and y1 plus y2 over 2. Okay, now because we labeled this as the first point, point 1, P1, we're going to say that's x1 and y1. Because I labeled the second one as the second point, I'm going to label this as q2 and y2. Okay, so let's substitute everything in. The easier numbers you can actually do mentally, but I'm going to be writing out the process. So we say 4 plus 6, then we're going to divide that by 2. The other side, we're going to say -3 plus -1 divided by 2. All right, 4 plus 6 is 10. 10 divided by 2 is 5. And then instead we have a -3 and -1, which is a -4 divided by 2. And -4 divided by 2 is -2. So then you have your midpoint, 5, -2. Now the distance formula is it's different. It looks scary, but it's not. It's basically, I'm going to draw this out roughly. Draw kind of an approximation of this in the Cartesian coordinate system. Okay, so let's say this point over here is 4, 3. It's a 4, believe it or not. And let's say the point over here is 1, 1. Okay? And we want to find the distance between these 2 points. Now, if I kind of draw dotted lines through these, you can see, ooh, that looks terrible. You can see that this is something like, handshaking, sorry. It's something like a box here, or a square, or a rectangle, at least in this case, right? Now, we already know a relationship with the Pythagorean theorem, which is a squared plus b squared is equal to c squared, right? And that's basically saying if we have a right triangle, okay, then we can figure out the hypotenuse, right, by squaring and adding the 2 legs together. And then what we do is we want to find, that would give you c squared, or the hypotenuse squared. So if I just want to solve for the hypotenuse, what I would have to do is then take the square root of both sides to solve for the c, right there, the hypotenuse. You don't have to know how the distance formula is derived, but it does sometimes help to know how something's derived to understand kind of how to use it. So basically, if I'm trying to find the hypotenuse, I would take one of the legs, square it, add it to the other leg squared, and then I would take the square root of that sum, right? And that would be equal to the c, or the hypotenuse. Well, you can see that now that I've drawn this out, and then I know that looks terrible, but now that I've drawn this out, you can kind of see that I made a rectangle, right? So in fact, this is a right, sorry, not rectangle, triangle. I made a right triangle right here, right? So we actually get to use what we did here when we solved for c as trying to find the distance. So again, the distance between those 2 points is the hypotenuse. Okay, now, before I can do that, though, I need to know the a and the b to solve for the c. So this would be the equivalent of c here, right? Well, I need to find a. Well, what's a? Well, a is the distance between here and here. Well, how do you find the difference between those, the distance, right? Well, we would just say, well, 4 minus 1, and we would say, well, that leg length is a 3. Well, what about the other one? Well, we would find the distance between here and here, right? So that distance, and it looks like we would say something like 3 minus 1 is 2. So we would say that, right? It's 2. Okay? And then what we do is we plug it into this formula and we get it. Now that's why whenever you look at the distance formula, it has x2 minus x1 and y2 minus y1, because you're trying to find the lengths of those legs, and the way you find the lengths of those legs is the difference in the x values. It's the difference in the y values, and that's how you find it, right? And hopefully this kind of explains how the distance formula works and how it's related to the Pythagorean theorem. Again, you don't have to necessarily know this. You could just label everything thoroughly, plug it in, and you would get the correct answer, which is what we're about to do anyways. But hopefully this does kind of make sense, right? So again, you would just end up with, you'd end up with 3 squared, 3 squared plus 2 squared, square root is equal to c. And then you'd have 9 plus 4, and then you'd have 13 equal to c, right? Okay, so let's do an actual example where we don't, draw all this out. But essentially, let's say we label the first one as 0.1, and that would make that x1, and that would make that y1, right? And let's say the next point is going to be 0.2. So we could label this next one as, 0.2. And you could flip it. You could label the first one as 0.2 and this one as 0.1. It doesn't make any difference. The algebra will work out the same regardless in the end. Okay, so since we label this as 0.2, I'm going to label this as x2, and this is y2. Okay, now I'm going to plug everything in. So I'm going to say the distance d is equal to the square root of, and let's see if we want to find x2. Okay, so where's x2? Well, x2 is over here. It's the negative 5. And then we say minus, then we want to subtract the x1, and x1 is a 3. Then we're still going to square it. Then we're going to add that together. And now we say y2. y2 is a 3 minus, and then we want to subtract y1, and y1 is a negative 4. Be very careful with your signs there, right? You're subtracting a negative 4. You're not subtracting 4. Those will give you very different answers. So just be careful with your signs there, right? So in this case, we are saying negative 5 minus 5, which is negative 8. And then we're going to square it. Negative 8 times negative 8 is a positive 64. And then we're going to say 3 minus negative 4 is the same as 3 plus 4, which would give you a 7. And 7 squared is positive 49. Okay. Fair enough. And now we're going to say 64 plus 49. And it looks like that would give you 113, right? 60 plus 40 is 100. 4 plus 9 is 13. 113, right? And that is the distance. Now, it doesn't look like 113 is going to simplify. So in this case, you're probably done with your radical. If you could simplify it, you should simplify it to get full credit. And that's it.